Hello friends, welcome to my channel Control System Engineering. I, Professor Darshan Thakur, is going to explain this technique whose name is nothing but block diagram reduction. Right. So as far as this block diagram reduction technique is concerned, this technique is being specially used to determine the overall transfer function of that system by adopting certain reduction rules, right? So in your university question paper, most of the times, definitely we are having at least one numerical which is based on this block diagram reduction technique, in which the objective will be to determine the overall transfer function of that system by using certain reduction rules, right? So before going for that numerical, first of all we will try to learn the different reduction rules those are being used in this block diagram reduction technique, right? So that first rule is nothing but what? When the blocks are connected in series form, right? So such type of scenario we are having, this is very simple rule. As we are having these two blocks, their gains are nothing but this G1 as well as G2, and this is R stands for input and C stands for output, right? So series in the sense we don't have any subsequent elements which is connected in between these two blocks, right? So at that time these two blocks are connected in series form, right? So whenever they are connected in series form, so at that time we need to remember that their gains are being multiplied with each other. So as a result of multiplication, its overall gain will become G1 into G2. This is nothing but what? R, and this is nothing but what? C, right? So here C equals to what? R times of G1 into G2. Another important thing as far as this block diagram is concerned, this output C, always it equals to the input multiplied by gain, right? So as these two gains are being multiplied with each other, because these two blocks are connected in series form, so its overall output will become what? Here C equals to R times of G1 into G2, right? So this is rule number 1. Similarly, rule number 2 is nothing but whenever the blocks are connected in parallel form, so at that time we are having the influence of this summing point fellow. If suppose this is G suffix 1, this G2, and this is nothing but what? G3, and the same input is being given here to this block, that is nothing but R. This is how this scenario will look like, and this is C, right? So at this point these three blocks are connected in shunt form. Why? Because these three blocks are being terminated with this summing point. To that summing means what? We can either add or we can subtract, right? So with the help of these summing points, their outputs are being added or subtracted with each other. So as a result of doing this, as you can see here, we are having the plus, this is also plus, and this is nothing but what? Negative sign we are having. So these two signals are being added with each other, and the sum of these two signals is being subtracted from this lower signal, right? So its overall output will become what? As I told you earlier, what will be the output of this first block? Gain multiplied by input. So R into G1. Similarly, R times of G2 and R times of G3, right? Because the same input is being given. So C equals to what here? C equals to R times of this G1 plus G2 minus of G3, right? This is how this rule number 2 elaborates that whenever the multiple number of signals are connected in shunt form, so according to this mathematical sign, they are either added or they are either subtracted with each other with the help of this summing point, right? So this is reduction rule number 2, right? Then reduction rule number 3 is nothing but how to eliminate the feedback. Let us quickly go through this reduction rule number 3, in which we will come to know, or we will try to learn how to eliminate the given feedback signal, right? So closed loop means what? It deals all about this feedback signal. So we are having either positive feedback or either we are having the negative feedback. So see, this is how this closed loop system will look like. This is input and this is nothing but what? Output. And here either we can have the positive feedback or negative feedback, right? So the gain of that forward path is nothing but G, and the gain of that feedback path is nothing but what here? Capital H, right? So here C equals to what? C is nothing but desired output, in which we will try to eliminate this feedback, right? So always you need to remember that the C equals to, it is G over 1 plus minus G into H. This is how that feedback is being eliminated, right? So what is the value which is coming out of from that entire system? C equals to, its numerator will be what? The gain of that forward path, G. As far as its denominator is concerned, so we are having either plus or minus sign within its denominator. It depends upon what kind of feedback we are having, right? If we are having the positive feedback, so its opposite sign we need to consider. We need to consider the negative sign. If we are having the negative feedback, so opposite sign we need to consider. We need to consider the positive sign, right? So as a result of this, if it is a negative feedback, so overall gain will become G divided by 1 plus G into H, right? If we are having the positive feedback, so opposite sign we need to consider, it will become G over 1 minus G into H. So in this way that feedback is being eliminated, right? This is rule number 3. After that, rule number 4 is nothing but what? Associative law. This associative law purely deals with this fellow, that is nothing but what? Summing point, right? So what this associative law will try to tell us, that whenever the n number of summing points are connected in series form, so at that time, according to our own convenience, we can change the order of these summing points. So to learn this reduction rule, let us consider the scenario in which, as you can see, we are having two summing points. This will be S1 and this will be S2, right? So summing points means these two signals are being subtracted with each other. Again, these two signal levels are being subtracted with each other. It operates upon what kind of mathematical sign we are having with us, right? So this associative law says that whenever the n number of summing points are connected in series form, means we don't have any subsequent term which is connected in between these two summing points. So at that time, according to our convenience, we can change the order of this n number of summing points, right? To understand this rule, let us quickly declare what this C stands for here, right? To generate this C, first of all, we need to determine this Y, that is nothing but what? The output of first summing point. So how to get this Y here? Y equals to what? It is R minus of B1, that is nothing but Y. So R minus of B1, right? And what is the output of second summing point? C equals to Y minus of B2, right? C equals to Y minus of B2. So it will become R minus B1 minus B2. This is the entire statement, right? So when we change the order of these two summing points like this, if suppose this will be the S2 here, which potential we are having? B2, and this will be the first summing point S1. So at its lower terminal, we are having this B1 along with this negative sign, right? This Y will remain same, it will retain its position as it is. This is nothing but R, right? So at this stage, Y equals to what? This R minus of B2 is nothing but Y. And what this C stands for? C is nothing but what? It is Y minus of B1. So it will become Y is nothing but R minus of B2 minus of B1. Means we can retain the same statement as compared to the first one. Here R minus of B1 minus B2. It is as good as R minus of B2 minus B1. Means we can definitely change the order of these summing points whenever they are connected in series form. So this is nothing but what? Rule number 4, right? So total we are having 8 basic rules. So out of that 8, first these are the first 4 rules. As far as the remaining 4 rules are concerned, those are belongs to the summing point and takeoff point. Means how to shift this summing point before this block, after this block, and how to shift this takeoff point before and after this block. Let us quickly go through this remaining 4 points. Then after that we will try to discuss one important numerical which is based on this block diagram reduction technique. So now rule number 5. So in case of rule number 5, let us consider we are having one situation in which we are supposed to shift. First we will consider the summing point, right? How to shift the summing point before and after this block. So consider such type of situation we are having with us, in which if suppose this is gain of that forward path G1, and here we are having this summing point fellow whose potential is X, and this is nothing but what? C. So this is R. If suppose we are having the positive sign here, right? So now we are interested to shift the summing point before this block whose gain is exactly equals to how much here, G, right? So in order to learn this reduction rule number 5, first of all we need to declare the desired output statement, that is nothing but what, C. So C equals to what here? To have the desired value of this C, the desired value of that C is generated out of the summing point. So to this summing point we are having two different potentials, right? This is the upper one and this is the lower one. So what is the desired signal which is present at that upper terminal? The output of this first part, that is nothing but what, which contains this R as well as G1, right? So the output of that block is nothing but what, gain multiplied by input. So the output of this block will become R times of G1, right? This is the potential which is present at the first terminal of the summing point. The potential which is present at the second terminal of that summing point is nothing but capital X, right? So by taking into account this fact, this C equals to what? R times of G1 plus X, right? This is the desired statement which we want, even though that summing point is being shifted before this block, right? For that purpose, we need to declare that statement first, right? So when I shift this summing point directly before this block whose gain is exactly equal to what here, G1, then what will happen? See, this is C, this is nothing but what, R. When that summing point is being shifted, so at that time okay, so rule number 5 of this block diagram reduction technique, as I told you earlier, rule number 5, 6, 7, 8, these are belongs to the summing point and the takeoff point. So let us consider the scenario in which, if suppose this is the gain of that forward path and here we are having this summing point, this is input R, this is output C, and this is the magnitude of this summing point terminal X along with this mathematical sign plus like this, right? So in this scenario we will try to learn how to shift the summing point before this block, right? So before shifting the summing point before this particular block whose gain is exactly equals to capital G, first of all we need to define the overall output statement of this system, right? So here C equals to, first of all we need to define this term, right? So as you can see, with the help of this summing point, these two signal potentials are being added with each other to have the desired statement belongs to this C. So one by one we will try to declare these two potentials. As far as the first potential is concerned, which is the output of this particular desired path, right, which consists of this G and R. R is nothing but the desired input which is given to this block whose gain is nothing but G. So its output will become what? The input multiplied by gain, R into G, right? So Rg is nothing but the potential which is present at the first terminal of this summing point. Similarly, the potential which is present at the lower terminal of this summing point is nothing but capital X. So by taking into account this fact, here C equals to what? Rg plus X. This is the desired statement, right? Now when we are about to shift this summing point before this block, right? If I shifted this summing point without doing any kind of modification like this is R. This is the potential of this summing point, and X, this is G and C, right? Then what this C stands for here, as you can see, as far as the summing point is concerned, so these two signals are being added with each other. This input and the lower terminal potential is nothing but what? X. So at this particular point, what kind of input is being given to this block whose gain is nothing but capital G. So its input is nothing but what? Up to this point, the signal level is R plus X is being given to this block whose gain is nothing but capital G, right? And at that point, the output of this block will be what? R plus X into G, the input multiplied by its gain, right? So if you multiply this G with this parenthesis, it will become Rg plus Xg, which is not equal to this first term, right? In that first scenario, what we want, we should retain this equation C equals to Rg plus X, right? So in order to retain that original output equation in that first scenario, while shifting the summing point before this block, what we need to do here, we are supposed to add one more block to the lower terminal of this summing point here, The potential is what? Just exactly similar to the previous case, that is nothing but what? Capital X, right? So in order to shift the summing point before this block, one more block is being added whose gain is exactly equals to the reciprocal of that original one. Here the gain of this previous block is nothing but what? G. So the reciprocal of G is nothing but what? 1 over G. Then and then only we can retain the same statement here, right? As a result of doing this, what will happen here? What kind of input is being given to this block? In the previous case, without doing any kind of modification, its input is what? R plus X, right? In this particular case, now what kind of input is being given to this block? This R plus X by G, right? Because 1 by G is nothing but what? It is the gain of that newly added block. And what kind of input is being given to that newly added block? Capital X. So its input multiplied by gain, as a result it will become X over G, right? Now this input is being given to this block whose gain is nothing but what? G. To generate the desired statement belongs to this C, right? So when this G is being multiplied with this parenthesis, so it will become Rg plus X, right? Which exactly equals to the previous one. The same statement we want here, Rg plus X. So this is rule number 5, which says that in order to shift this summing point before this block, we need to add one more block to the lower terminal of the summing point whose gain is exactly equals to the reciprocal of that original gain. If it is G2, so here it will become 1 over G2, right? If it is capital G, so it will become 1 over G. Then and then only we can retain this output equation. So this is rule number 5. In same manner, rule number 6. This rule number 6 is about, this will tell us how to shift this summing point after this given block. That is rule number 6, right? So let us consider the scenario belongs to this rule number 6. Here we are having the summing point, this G, this is nothing but what? C, R, this is nothing but X, right? So in this scenario, first of all, before shifting the summing point after this block, we need to define the overall output statement, right? So with the help of the summing point, these two signals are being added with each other, right? Because we are having the positive sign here. If you are having the negative sign, so those two signals are being subtracted with each other. So in this case, what kind of input is being given to this G? This R plus X is nothing but input which is given to this block whose gain is nothing but G. So what will be the output of this block? The input multiplied by its gain. So it will become R plus X into G is nothing but C. So it will become Rg plus Xg is nothing but C, right? This is the desired output statement, right? In order to shift the summing point after this block. Now in that second case, if I shift the summing point after this block like this without doing any desired modifications, as it is, this is R, this is X and this is C. So in that case, we are getting C equals to what? That we need to determine here. The potential which is present at this particular terminal of this summing point will be the output of this path, input multiplied by gain, so it will become R into G as far as the lower terminal is concerned. So which potential is lying at this lower terminal, capital X. So these two signals are being added with each other because we are having the plus sign here, right? So here C equals to what? C equals to this Rg plus X. But we should retain the original statement which is in this form Rg plus Xg, right? What it is? It is Rg plus X times of G equals to C, right? So in order to retain that statement, what we need to do? Obviously we need to add one more block to the lower terminal of this summing point whose gain is exactly equals to capital G, right? By adding this block, what will happen? Up to this point, the potential is what? R into G. As far as this newly added block is concerned, whose gain is nothing but just exactly similar to the previous one, right? Capital G. And what input is being given to that G? Capital X. So the potential which is present at the lower point of this summing point will be, instead of only X, it will become G times of X, right? It will become G times of X. So in this way, that original statement is to be retained, Rg plus Xg or Rg plus Gx. It is one as the same, right? So in order to shift this summing point after this block, what we need to do? We need to add one more block to the lower terminal of that summing point which is to be shifted, whose gain is exactly equals to the gain of this forward path. That is nothing but what? If it is G1, it will be G1, G2, G3, whatever it may be, right? Now this is rule number 5. Now as far as the remaining 2 rules are concerned, these 2 rules belongs to the takeoff point. How to shift this takeoff point before this block and how to shift this takeoff point after this block. So one by one we will try to learn these 2 reduction rules belongs to takeoff point in case of this block diagram reduction technique, right? So immediately we go for this rule number 7. In this, how to shift this takeoff point before this block. Now see, takeoff means what? Takeoff means some part of that output is being taken off towards the input. That is the significance of this takeoff point. So usually it falls in case of that feedback signal, takeoff point, through that takeoff point that feedback is being given towards the input, whether it is positive or negative. Now in this scenario, we need to shift this takeoff point before this block. So before shifting this takeoff point before this block, whose gain is nothing but capital G, we are supposed to declare its overall output statement, that is nothing but what C. So let us go through this case. So here at this, up to this point, the signal potential is what this arrow indicate? The output of this block. What kind of input is being given to that block? R. The gain of that block is nothing but what? G. So the gain multiplied by input. So here at this point, the signal potential is what? Rg, right? And the same potential will present at this takeoff point. X stands for what? It is the magnitude of that takeoff point. So X equals to what? R into G, as well as C equals to what? R into G, right? So these 2 statements we need to retain in terms of C and in terms of magnitude of this takeoff point X. C equals to R into G and X equals to what? Again it is R into G. So when I shift this takeoff point before this block in this scenario like this is R and this is nothing but what? X, and this is nothing but what? C. So let us see here. Here first of all we need to determine C. What will be the overall output statement? What we want? We want C equals to R into G. So let us check whether we are getting C equals to R into G. Here C is nothing but what? The output of this block. What kind of input is being given to that block? That is nothing but what? R, right? So input multiplied by gain. So obviously C equals to R into G. These 2 statements are match. We are getting the same statement in case of C, right? Then what about this X? X is nothing but what? The magnitude of this takeoff point. In this lateral case, X equals to what? R itself is X. In that previous case, we should retain this statement X equals to in terms of R into G, right? So in order to have the desired value of this X, which exactly equals to how much? R into G, simply what we need to do? We need to add one more block here towards the lower terminal of this takeoff point, whose gain is exactly equals to how much here? G. And here we are getting the magnitude of this takeoff point, just similar to the previous one, right? So in the once that block is being added, while shifting this takeoff point before this block, whose gain is exactly equals to G, similarly the gain of that newly added block, it should be exactly equals to the gain of that previous block, right? What it is G, right? So in that case, see, what will be the output of this path? The output of this path is nothing but what? X. What kind of input is being given? Here this R, and the gain of this block is nothing but what? G. So X equals to R into G. X equals to R into G and C equals to R into G. So in this way, this takeoff point is being shifted before this block by adding this one more block whose gain is exactly equals to the original forward path gain. That is nothing but what? G. To retain these 2 statements. So this is nothing but what? The rule number 7. Similarly, last one, or the rule number 8 of this block diagram reduction technique. Apart from these 8 rules, again we are having some critical rules. Those are which are belongs to this summing points and takeoff point key. How to shift this takeoff point before this summing point, and how to shift this summing point before this takeoff point and after this takeoff point. But those rules are very rarely used in this block diagram reduction technique. So currently reduction rule number 8 belongs to takeoff point. How to shift this takeoff point after this block. So for that, consider this scenario in which this is the gain of this forward path. This is nothing but what? C. And this X is nothing but what? The magnitude of this takeoff point, right? here x equals to what? R itself is x, right? R itself is the x, and what this C stands for? C is nothing but the output of this block. So how to get the output of this block? These two signals are being multiplied with each other, so C equals to R into G. So these two statements we need to retain while shifting this takeoff point after this block, right? So in that lateral part, when I shift this takeoff point after this block directly like this, if suppose this is R, this is the magnitude of this takeoff point x, and this is nothing but what? C, right? So initially here C equals to what? The output of this part is nothing but C, so R into G is nothing but what? C. Just exactly similar to the previous case. That statement is being written. But what about this x? We want x equals to what? X equals to R. In this case, x equals to what? See, the output of this block is nothing but what? Is the magnitude which is present at this x. So the output of this block is nothing but R into G, right? Which is not equal to the previous case. What we want? We should have x equals to R, right? Currently we are having x equals to R times of G, right? So in order to eliminate this additive G, what we need to do? We need to add one more block whose gain is exactly equals to 1 over G, and this is nothing but what? X, right? Now once that block is being added whose gain is exactly equals to the reciprocal of that original one, right? So at that time what will happen? Up to this point the signal level is what? Rg, right? So this Rg is being given as a input to this block, and the output of that block is nothing but what? Here xc. So x equals to what? Rg times of 1 over G, because Rg is nothing but what? The output of this part which is given as an input to this block, right? And this input is being multiplied by the gain of this block, so it is 1 over G. So obviously G will get cancelled. X equals to what? R. The same statement we want here, right? Means in that reduction rule number 8, in order to shift this takeoff point after this given block, we need to add one more block whose gain is exactly equals to the reciprocal of that original one. So this is all about the 8 different reduction rules. After this rule, now we will try to discuss one very important example belongs to this block diagram reduction technique. Okay, so this is the numerical belongs to the block diagram reduction technique. Already we had discussed the basic 8 rules of this block diagram reduction techniques, right? So let us quickly go through this numerical, in which first of all we need to obviously understand what is our objective. So our objective is to determine the overall transfer function of this control system, which is represented in terms of this block diagram representation, right? So as we know, this transfer function is what? It is nothing but it is the ratio of output to the input in terms of S domain, right? So C of S upon R of S. So obviously R of S is nothing but the desired input, and the generated output is nothing but what here? C of S. So along with this R and C, again the fundamental components of this block diagram representation technique, we are having finite number of summing points. Like if suppose this will be the first summing point S1, this will be the second summing point S2, this will be the third summing point S3. We are having 3 summing points. Similarly, we are having n number of takeoff points. So from sake of observation, we are coming on to this conclusion. There are 2 takeoff points. This will be the first one and this will be the second one. So roughly we need to mark the summing points as well as takeoff point, right? To decide which step we need to include, right? To determine its overall transfer function, right? So in that first step, what we need to do? We need to map this given control system with respect to that 8 different rules which we had discussed, right? Blocks in series, blocks in parallel, how to eliminate the feedback, associative law, right? And as far as the remaining 4 laws are concerned, those are belongs to shifting of summing point and takeoff point before and after this block, right? So out of that 8 block, first of all, we need to map this given control system which rule is being adoptable in that first step, right? So it is very clear that we don't have any blocks, those are connected in series form, but surely we can adopt the strategy belongs to reduction rule number 2, because as you can see, as far as the summing point number 3 is concerned, So these two signal levels are being added with each other, right? So definitely we can say that this portion and this portion means ideally these two blocks are connected in parallel form, right? So those are being added with each other. In that first step, definitely we can follow the reduction rule number 2, right? So here the gain of that first block is nothing but what, G3, and the gain of that second block is nothing but what, it is a unity feedback, sorry, it is a we can say that the desired value of this signal is exactly equals to 1. So unity forward path, we can say that, right? So these two signals are being added with each other. So this is the first step, right? Then within that same step, as you can see, we can use the reduction rule number 3, which says that how to eliminate the feedback, right? So we need to recall these two rules. Key blocks, those are connected in parallel form. If suppose this is G1, this is G2, these two signals are being either added or these two signals are being either subtracted with the help of this summing point. So its overall output will become what? G1 minus G2 times of R equals to C. This is nothing but what? Rule number 2. And rule number 3 is nothing but what? Whenever we are having such type of closed loop system, right? So at that time, as you can see, this is R, this is nothing but what? C. So here either positive feedback or negative feedback. But currently, as far as this system is concerned, so the innermost feedback, right? Which mathematical sign is being denoted here? Negative, right? So it is nothing but what? Negative feedback is being used. Another unique identity belongs to this feedback loop is nothing but the gain of that feedback signal is exactly equals to 1. Means obviously it is H equals to how much here? 1. It is a unity feedback system. Now how to eliminate that feedback? Already we had discussed. Here C equals to what? G divided by 1 plus G into H. Here H equals to how much? H equals to 1. So it will become G over 1 plus G. Here G is nothing but what? This G2. So initially these two rules we need to use in that first step, right? Blocks, those are connected in parallel form, as well as how to eliminate this feedback. So the first step becomes what here? This feedback is being eliminated, as well as these two signals are being added with each other. Remaining things as it is, so it will become in that first step this G1, this summing point will retain its position as it is. Only thing is these two signals are being split, because this lower signal is nothing but what? The innermost feedback, which is to be eliminated now. As a result of elimination, it will become G divided by 1 plus G into H. So it will become G2 divided by 1 plus G2, because it is the unity gain feedback, right? At the same time, these two signals are being added with each other. So as a result of addition, it will become G3 plus 1, right? Remaining things as it is. This is nothing but what? This feedback fellow H1. Here we are having this takeoff point along with this summing point, like this. Hereafter we are having this fellow called as a H2. This is C of S. Here this is nothing but what? R of S, right? As far as the feedback is concerned, so one more time we need to retain all these signs. This is the negative feedback. Here we are having two positive polarities. This is positive and this is also positive, right? So in that first step, this is how your system will look like. As a result of elimination, this innermost feedback and these two blocks are connected in parallel form, so their gains are being added with each other, right? So in that next step, now what we need to do here? In that next step, now we don't have any blocks, those are connected in series form, right? Again, we cannot use this reduction rule number 2 as well as reduction rule number 3. In order to use this reduction rule number 3, in order to eliminate this feedback, we are having this summing point within that loop. So we are supposed to remove that obstacle, or we need to remove that barrier, right? So here, which rule is adaptable in that second step? Here, as you can see, this is nothing but what? Takeoff point number 1, right? We need to shift this takeoff point number 1 after this block, whose gain is nothing but what? G3 plus 1. So simply we need to recall this reduction rule number 7 or reduction rule number 8, in which how to shift this takeoff point how to shift this takeoff point after this block. Here x is nothing but what? The magnitude of this takeoff point. X is nothing but what? R. This R itself is a x, and here C equals to what? The output of this path R into G. So C equals to R into G. In order to shift this takeoff point after this block, what we need to do? We need to add one more block whose gain is exactly equals to what? Whose gain is exactly equals to the reciprocal of that original block, that is nothing but what? G. Then and then only we can retain these two statements. As a result of doing this, what will happen here? This is nothing but what? The magnitude of this takeoff point. Up to this point, the signal level is what? R into G. So C equals to what? R into G. First statement is being satisfied, right? Remaining statement is nothing but what? Here we want x equals to R, right? So x is nothing but what? The output of this block, right? The output of this path, that which involves this takeoff point, right? So what kind of input is being given to this block? R into G. So x equals to what? Input multiplied by gain. So Rg into 1 over G. So this Gg will get cancelled. It equals to what? R. So in this way, this statement is being also written, x equals to R, right? So what we need to do in order to shift this takeoff point after this block, once the takeoff point is being shifted after this block, we need to add one more block to the lower terminal of this takeoff point whose gain is exactly equals to the reciprocal of that original one. So that we need to use in this step, right? So as a result of doing this, here we need to map which takeoff point we need to shift, and while shifting this takeoff point, what will be the gain of this newly added block? That depends upon the gain of this desired block is exactly equals to how much we are in need of shifting takeoff point after this block, whose gain is nothing but G3 plus 1, right? So once that takeoff point is being shifted after this block, we need to add one more block whose gain is exactly equals to the reciprocal of this G3 plus 1. So it will become 1 over G3 plus 1. So as a result of doing this, once this takeoff point is being shifted, see here, within the same step, right? Once this takeoff point is being shifted towards or after this block, like this. So here we need to add one more block whose gain is exactly equals to the reciprocal of this original one, 1 over G3 plus 1. But what will happen once that takeoff point is being eliminated? So these two blocks are connected in immediately series form. So their gains are being multiplied with each other, right? So within the same step, we are going to perform the two different things. Out of that two different scenario, first one is nothing but we are shifting this takeoff point after this block, because here we are having this takeoff point. That takeoff point is being shifted after this block. So as a result of shifting, one more block we need to add whose gain is nothing but what? 1 over G3 plus 1, reciprocal of that original one, right? And within the same step, once that takeoff point is being shifted, so these two blocks are connected in series form, because we don't have this takeoff point no more with us, which is present in between these two blocks. So these two blocks are connected in series form, so their gains are being multiplied. So the second step will become what here? This G1, it will retain its position as it is. The summing point also, it will retain its position as it is. Now these two blocks are connected in series form, so those are being multiplied. G2, I will put this term into this parenthesis, G2 into G3 plus 1 divided by 1 plus G2, right? Again, as it is, this feedback element belongs to H1, right? Now when this takeoff point is being shifted after this block, right? Here that takeoff point is being shifted, so here we need to add one more block in this fashion, right? Whose gain is exactly equals to the reciprocal of this original one, so it will become 1 divided by G3 plus 1, right? And where that takeoff point is being terminated? To the upper terminal of the summing point number 2. So here we are having this summing point number 2. So where it is being terminated? It is being terminated to the upper terminal of summing point number 2. With which sign? With this positive sign, right? As far as the remaining terminal of that summing point 2 is concerned, so as it is, we need to include this feedback element, that is nothing but what? H2. It is connected like this, and this is nothing but what? C of S, and this is nothing but what? R of S. So in that second step, your system will look like this, right? Because this takeoff point is shifted after this block whose gain is nothing but G3 plus 1. So one more block is being added whose gain is reciprocal of G3 plus 1, 1 over G3 plus 1. Within the same step, once that takeoff point is being shifted, so these two blocks are being connected in series form. So their gains are being multiplied, right? Now after that, here which sign we are having? Here we are having the positive sign, right? So in that third step, right? In that third step, one more time, as far as the summing point number 2 is concerned, so these two potentials are being added with each other. Means we need to perform the addition operation. Means we need to use the reduction rule number 2, which says that whenever the blocks are connected in parallel form or in that shunt form, so with the help of the summing point, at that time their gains are being added with each other. Why? Because here also we are having plus and here also we are having the addition sign, right? So as a result of this, the gain of these two blocks are nothing but what? One block gain is 1 over, it is 1 over G3 plus 1 plus the gain of that another block is nothing but what? H2. So these two blocks are being added with each other. So as a result of addition, here this G3 plus 1 can be considered as a LCM term. So it will become 1 plus again G3 times of H2 plus H2, right? So as a result of addition, we are getting 1 plus G3 times of H2 plus H2 over G3 plus 1, right? So this is the desired term, right? Which will come out of this addition operation when these two blocks are being added with each other. Their gains are nothing but 1 over G3 plus 1 and another gain is nothing but what? H2. So step number 3, it will become what? From this step number 2, how that step number 3 is being defined. So for that purpose, I will remove this step number 1. We are having this step number 2 on this board, right? So in this step, what we need to do, these two blocks are being added. As a result of addition, their overall gain will become what? This entire statement which is written within this rectangular box. So here I will draw step number 3. Remaining parameter will retain their position as it is. This will be G1. This is our summing point number 1. This gain, this is nothing but what? G2 into G3 plus 1. Its denominator will be what? 1 over G2. Right? Then from this summing point with this negative sign, we are having one feedback element whose value is nothing but what? H1. Now this summing point number 2 is no more with us. Why? Because it is being eliminated as these two blocks are being added with each other. Their overall gain is nothing but what? Here I will write. It is 1 plus G3 times of H2 plus remaining term is nothing but what? H2. Its denominator is nothing but G3 plus 1. So this is how this block will look like once these two signals are being added with each other. So this summing point is being eliminated, remaining thing as it is. This is nothing but what? Feedback signal C of S. This is nothing but what? R of S, right? Now as far as this summing point number 1 is concerned, which mathematical sign we are having here? Negative, means we are having the negative feedback. So in that step number 4, clearly it is very clear that these two blocks are connected in which form? Series form, right? So their gains are being multiplied with each other. As a result of multiplication, this term will become what here? L. I will modify because these two blocks are now connected in series form, so their gains are being multiplied. So as a result of multiplication, the entire gain will become what? H1. I will put this term within this parenthesis, so it will become like this, right? Because once these two blocks are being added, their block addition is nothing but this particular block which is connected in series with this H1. So that's why these two blocks are being multiplied with each other. So currently our system will look like this, right? So in this step number 3, or in order to perform the next step, I will remove the previous step here. So clearly, as you can see now, which reduction rule we need to use? This entire portion that can be treated as a G, this lower portion can be treated as a H with the help of what kind of feedback we are having? Negative feedback, right? So we are supposed to use the reduction rule number 3, which says that how to eliminate either the positive feedback or negative feedback. Already that reduction rule number 3 is being adopted in that our first step, right? So same concept is being used here. Here only thing is what? Here G equals to, here I will write G equals to G2 times of G3 plus 1 over 1 plus G2, and H equals to what? H equals to H1 times of 1 plus G3 H2 plus H2 divided by its denominator will be what? G3 plus 1, right? So this is G and this is H. So as a result of feedback elimination, the feedback elimination will be what? It is G divided by 1 plus G into H, right? If you are having the negative feedback, opposite sign is to be considered within this denominator, right? So this entire term will become what here? Here I will write G2 into G3 plus 1. Its denominator is nothing but what? It is 1 over G2. This whole thing divided by 1 plus one more time this G means G2 into G3 plus 1 divided by 1 plus G2 into H. Here H is nothing but what? This whole term is nothing but H. H1 into 1 plus G3 H2 plus H2. So here I will write H1 into 1 plus G3 H2 plus H2 divided by its denominator is nothing but what? G3 plus 1, right? So simple mathematical simplification we need to do. As a result of simplification, this 1 over G2 can be considered as a LCM term, right? So at the same time this G3 plus 1 will get cancelled. So the overall system gain will become G2 into G3 plus 1. Overall system gain belongs to this step number 4. Belongs to this step number 4 in which that feedback is being eliminated. One more block we are having with us. Lastly, we will try to deal with this block whose gain is nothing but what? G1, right? So currently its denominator will be what? Its denominator will be what? This term will get multiplied with this one. So it is 1 plus G2 into 1 plus G2 plus G2 into H1. Remaining thing as it is 1 plus G3 into H2 plus H2, right? So this is, if I put this whole statement within this rectangular box, so what it is the result of how we had eliminated this feedback path where G equals to what? G2 into G3 plus 1 upon G2, and H equals to what? H is nothing but what? H1 into this whole parenthesis divided by G3 plus 1, right? So it is written in this manner, G divided by 1 plus G into H. As a result of this, its overall gain will become G3 into G3 plus 1 divided by 1 plus G2 plus G2 plus H1 into 1 plus G3 times of H2 plus H2, right? Now at this stage, this entire portion is being replaced with this rectangular box, right? Because this feedback is being eliminated, right? So as a result of replacement, here I will write as a result of replacement how it will look like. So this will be the last step, step number 5. So G1 into this, all these things which is written within this rectangular box, G2 times of G3 plus 1, its denominator will be what? 1 plus G2 plus G2 into H1, G2 into H1 into this whole parenthesis 1 plus G3 times of H2 plus H2. So this is how your system will look like in that last step, which consists of only 2 blocks. Here we are having C of S and here we are having R of S, right? So as you can see in that last steps, this entire control system by using certain reduction rules is being converted into these two identical blocks. Their gains are nothing but G1, and the gain of this whole block is written within this rectangular box, right? So finally we can say that these two blocks are connected in series form because we don't have any barrier which is present in between these two blocks. So these two blocks are, their gains are being multiplied. So as a result of this, it will become what? This G1 into this whole term. So here I will modify, right? So it is G1 into, that term is nothing but what? G2 followed by G3 plus 1, and this G1 is being removed. So this is the transfer function of that system, right? So the transfer function of this given system is nothing but what? This one, right? As I told you earlier, transfer function is nothing but what? It is the ratio of C of S upon R of S, right? So this whole quantity which is written within this rectangular box is nothing but the overall transfer function of this given control system by using or by adopting certain reduction rules which we had discussed earlier. So I just hope that you had understand this terminology, whose name is nothing but what? Block diagram reduction technique by using certain reduction rules which we had conducted in this particular session, right? Thank you.